cosmic behemoth. Scientists discover what may be the universe's most massive black hole. In a groundbreaking astronomical discovery, researchers have identified what could be the largest black hole ever measured in the cosmos, lurking within a distant galaxy nicknamed the Cosmic Horseshoe. This celestial giant tips the cosmic scales at a mind-boggling 36 billion solar masses. Enough to challenge our understanding of how massive these enigmatic objects can become. But here's where it gets truly fascinating. This monster is so immense that it warps the very fabric of space-time around it, creating a perfect ring of light from a galaxy positioned behind it. A record-shattering cosmic titan, this newly discovered ultramassive black hole pushes the boundaries of what astronomers believed possible. It approaches the theoretical maximum size limit for black holes in our universe and dwarfs the black hole at our Milky Way center by a factor of approximately 10,000. The colossal object resides within the Cosmic Horseshoe, one of the universe's most massive galaxies. This enormous celestial body distorts space-time so dramatically that it bends light from a more distant galaxy behind it, creating the distinctive horseshoe-shaped phenomenon known as an Einstein ring. According to research published in the monthly notices of the Royal Astronomical Society on August 7th, 2025. Scientists have calculated this behemoth's mass at approximately 36 billion times that of our Sun, a figure that challenges our comprehension of cosmic scale. Unveiling the ultramassive mystery. Scientists now believe that every galaxy harbors a supermassive black hole at its center, with the largest galaxies containing even more massive variants called ultramassive black holes. We're looking at potentially the most massive black hole ever discovered. Certainly among the top 10, explained Professor Thomas Collett from the University of Portsmouth. What sets this discovery apart is our confidence in the measurement. Most previous black hole mass calculations rely on indirect methods with significant margins of error. Our innovative approach provides unprecedented certainty about this black hole's true size. And this is the part most people miss. Understanding these cosmic giants isn't just about breaking records. It's about unlocking the fundamental processes that shape our universe. Revolutionary detection methods. The research team employed a groundbreaking combination of techniques to measure this distant giant. They merged gravitational lensing, the bending of light by massive objects, with stellar kinematics, studying how stars move within galaxies and around black holes. While stellar kinematics is considered the gold standard for measuring black hole masses, by incorporating gravitational lensing into our methodology, we've been able to extend our reach much deeper into the cosmos, Professor Collett explained. We confirmed the black hole's presence through two distinct observations. It alters light paths traveling past it, and it forces stars in its vicinity to move at extraordinary speeds, nearly 400 kilometers per second. The combination of these measurements eliminates any doubt about the black hole's existence and size. For beginners in astronomy, think of it this way. Imagine trying to weigh something extremely heavy from far away without touching it. You'd need to observe how it affects objects around it, how it pulls on them and changes their behavior. That's essentially what these scientists accomplished, but on a cosmic scale. The silent cosmic giant. Carlos Melo, the lead researcher and PhD candidate at Brazil's Universidade Federal do Rio Grande do Sul, UFRGS, highlighted another remarkable aspect of this discovery. What makes this finding particularly significant is that we detected a dormant black hole, one that isn't actively consuming material at the time we observed it. We identified it solely through its enormous gravitational influence on its surroundings, Melo continued. The most exciting implication is that our method enables us to detect and accurately measure these hidden ultramassive black holes throughout the universe, even when they're completely inactive. Measuring the distant and dormant. The Cosmic Horseshoe black hole sits at an astonishing distance of approximately 5 billion light-years from Earth. To put this in perspective, the light we're observing from this object began its journey when our planet was just beginning to form its first complex multicellular organisms. For such remote cosmic objects, black hole measurements typically require the black hole to be actively feeding on surrounding matter, Mello explained. However, those estimates based on accretion processes often contain significant uncertainties. Our approach, which combines strong gravitational lensing with stellar dynamics, provides a more direct and reliable measurement, even for these incredibly distant systems. It's like having a cosmic scale that works across billions of light-years. Black holes and the evolution of galaxies. This discovery carries profound implications for our understanding of how galaxies and their central black holes evolve together throughout cosmic history. We believe the growth of galaxies and their central black holes is intimately connected, Professor Collett noted. As galaxies expand, they channel matter toward their central black holes. Some of this material increases the black hole's mass, while much of it radiates away as an intensely bright energy source called a quasar. These quasars release tremendous amounts of energy into their host galaxies, preventing gas clouds from condensing to form new stars. For context, our own Milky Way contains a relatively modest supermassive black hole weighing about 4 million solar masses. While it's not currently growing rapidly enough to generate quasar-level energy, evidence suggests it has done so previously and may do so again. In fact, astronomers predict that when the Andromeda galaxy collides with our Milky Way in approximately 4.5 billion years, this